Okay, hey everybody, do watch this recording. This recording is about parallel plate capacitor, okay, and factors which can affect the capacitance of a parallel plate capacitor. So, in case if you want to know what is capacitor, please do watch my previous video. In that I explained that capacitor is like a battery. It can store charge. We can charge it, we can discharge it like a battery. So here we are going to learn about the capacitance and factors which can affect the capacitance of a capacitor. So let's begin. So like I have explained in the previous video, it is used to store the charge. As you can see here, 12 volt battery is connected to the capacitor plates, and now you can see the charges on the capacitor. So the potential difference between these two plates will be 12 volt. Okay, so it's like a battery. Okay, fully charged capacitor. In this case, when it is fully charged, the potential difference between these two plates will be 12 volt. So I am using 12 volt battery. This is DC current. It will charge up to 12 volt. And if I connect it to the load, it will get discharged. So in place of 12 volt, if I increase the voltage, suppose that if I use 20 volt battery, 20 volt, okay, so my capacitor will store more charges, okay, and potential difference will be more. So suppose that if I use 20 volt battery, it will store potential difference of 20 volt. So it's like a battery in short, I can say that. So well, there is a equation here. What is the meaning of this equation? There are few equations which are related to capacitor. Okay, we will learn about them step by step, one by one. Now let's try to understand the meaning of this equation. Like I said, if I use 12 volt battery, potential difference across the plates when the capacitor is fully charged will be 12 volt. If I use 20 volt, fully charged capacitor will have 20 volt potential difference. It will hold more charge. So what is the meaning of that? It means if I increase the potential difference, if I increase the potential difference of the battery, the capacitor will charge more, okay, it will hold more charges. So more potential difference, more voltage of the battery, capacitor will hold, acquire more charge. So they are directly proportional. So now here proportionality constant will be C. C is the proportionality constant. We call it capacitance. Okay, capacitance. So basically in this video we are going to learn about capacitance. It's a property of a capacitor. So basically on capacitor, its capacitance is mentioned. As you can see here in this case, it's mentioned on this 4700 mu for micro, F for farad. Farad is the unit of capacitance. So let's learn more about capacitance. Coming back to this equation, like I said, if the voltage of the battery is more, capacitor will hold more charges, okay, potential difference across the plates will be more. So I can write this equation, and proportionality constant is coming, we call it C. C stands for capacitance. So this is the definition of capacitance. It is the ability of the capacitor to hold or store charges, capacitance. So let me repeat once again. If you increase the voltage, potential difference across the parallel plate capacitor will also increase, means it will hold more charges. So charges acquired by the parallel plate depends upon the potential of the battery. More potential difference created by the battery, it will hold more charges. C is the proportionality constant. Let me keep C on one side. Okay, so what is the unit of charge? Coulomb. And unit for the potential difference is volt. So this is the unit of capacitance, Coulomb per volt, or Farad. Farad. Farad is the name of a scientist, Michael Faraday. In the honor of Michael Faraday, we use Farad. So like I said, on capacitors, their capacitance is generally mentioned. So there is one more formula related to capacitor and capacitance. This is the one. This is what we have seen so far. We just saw it, right? Now capacitance can be written in terms of area of the plates and separation between them. And this is the dielectric constant or permittivity of the free space. So permittivity I have explained in the first video. Each and every medium has a permittivity. Permittivity related to electric field. Okay, so I will explain that in short as well. In case if you have not seen the first video, do watch it. These are the factors on which capacitance of a capacitor depends. Now there is a derivation for this. I'm not going for the derivation part. Okay, otherwise lecture will be too long. It will be very lengthy. So I'm skipping that part. I'm just going to explain that capacitance depends upon area of the plates and distance between them. And there is one more factor. Okay, so let's learn about those factors. So basically these are the three factors on which capacitance depends. Area of the plate. Let me write down the equation. Area, more capacitance. So what is capacitance actually? Capacitance is nothing but the ability of the capacitor to store charges. So obviously अगर area of the plate ज़्यादा है तो it will hold more charges, right? And second factor is distance between them. So if the distance between the capacitor is more, capacitance will be less, inversely proportional. And then dielectric inside the capacitor. So I have already explained dielectrics in the first video. In case if you have not seen, kindly do watch it. अच्छा यहाँ पे permittivity भी आता है, permittivity of the free space. Generally capacitor is filled with the air. This capacitor, there is nothing in between, so it is filled with the air. Okay. Even this capacitor, nothing is there between the parallel plates, means air is there. So in that case, okay, check this one. There are two plates. If I want to make a capacitor using these two plates, okay, as you can see here, the area is more. Okay, effective area between the plates is more. So in this case capacitance will be more, because according to the formula, this is our formula, right? So if the area is more, capacitance will be more. And as you can see here, effective area between the plates are less, so capacitance will be less. So this is one of the factor, area of the plate. Less plate area, less capacitance. Obviously, what is the meaning of this actually? In this case, they will hold more charge, right? Large plate means they will hold more charge. So this is what capacitor do actually. They store charge. Okay, so if the area is more, they will store more charge. Okay, and capacitance will be more. Q is equal to CV according to the formula we have seen previously. Second factor is the distance between the parallel plates. So here the distance is less, capacitance is more. Here the distance is more, capacitance is less, means they are inversely proportional. So according to this formula, capacitance, permittivity of the free space, we are assuming there is air inside, directly proportional to area, inversely proportional to the distance between them. So this is the formula basically for the capacitance of the capacitor. There is derivation as well, which I am not going to go for. otherwise video will be quite lengthy. Okay, this is charge capacitor. We know that there exists electric field between the plates. So electric field always starts from negative charge and it ends into negative charge, right? So there is an electric field between the parallel plates. Now how can we change this electric field? Is there any method to reduce this electric field or increase this electric field? Let's find out. So far we have seen that capacitance depends upon area and distance between the plates. Third factor is dielectric inside the capacitor. Here this is permittivity of the free space or air. Okay, when we fill any dielectric between the capacitors, its capacitance will increase. So let's check that as well. So basically this is air filled. So in this case my equation will be directly proportional to area of cross section and inversely proportional to the distance between them. If I filled it with the dielectric slab, like in this case, okay, they have charged the capacitor and they have inserted one dielectric slab inside. In this case my capacitance will increase. Okay, capacitance means ability to hold the charge will increase. So this is for this capacitor, air filled. For this capacitor in which I have inserted dielectric, my equation will be K time epsilon naught A D. Okay, इसका मतलब है if I take it as original capacitance, final capacitance after inserting a dielectric will be like this. Okay, this is original capacitance. So it means, now what is K here? K is dielectric constant, which I have explained in first video. I hope you are aware of what is dielectric constant here. Each and every material is having its dielectric constant. So when you insert dielectric slab inside, its ability to hold the charge, its capacitance will increase. So effect of dielectric are insulating materials, non-conductors, also known as insulators. Okay, so when you insert dielectric in parallel plate capacitor, its capacitance increases K times. Okay, so this is the formula, as you can see here, dielectric constant. So these are the materials we use as a dielectric medium. Okay, air, when there is nothing inside the capacitor, we assume air. So in that case we write the formula epsilon naught A by D. If I fill the capacitor with mica, its dielectric constant is K. So if I fill the capacitor with mica, my capacitance will increase 6 times. Okay, so my final capacitance will be 6 times original capacitance. Okay, I need to add K in that case. So K times my capacitance will increase. Why does it happen actually? What is the reason for that actually? That is the main thing. So let's learn about that. So basically when you fill capacitor with dielectric, okay, they induce electric field inside the dielectric. So due to this induced electric field within the dielectric, the electric field between the parallel plate will get reduced by K times. The electric field is getting reduced K times, so even the potential difference between the plates will get reduced K times. Okay, because of this induced electric field. Okay, these are the polar molecules. When you keep them in electric field, they align in the same direction. Okay, in opposite to the direction of electric field. This is I have explained in my first video. Okay, I'm not going to explain this here because otherwise my lecture will be quite lengthy. So I hope you are aware of this. Okay, when you keep any dielectric material in external electric field, so they will align in the opposite direction to the external electric field, and they will try to oppose the external electric field. So the electric field का जो value है वो decrease हो जाता है basically. We call it polarization. Yeah, this is the thing. Okay, unpolarized atom, when you keep them in external electric field, okay, suppose that there is an atom, plus sign, negative sign. So when you keep them in external electric field, what will happen? External electric field is in this direction. Now negative charge will come on this side. Negative charge of this atom will come on this side. And sorry, wait a second. Negative charge will come on this side, positive charge will shift this side. So basically the atom is creating its own electric field in the opposite direction to the external electric field. We call it polarization. And due to this opposite induced electric field, ये जो external electric field है उसका effect reduce हो जाता है. Okay, reduce हो जाता है. So same thing is happening here as well. The induced electric field is in opposite direction. So electric field will get reduced by k time. Even the potential difference will get reduced by k time when we insert dielectric inside the capacitor. So like I said, when we insert dielectric inside, potential difference will reduce by k times. So if the potential difference is getting reduced, capacitance will increase because they are inversely proportional. So this is the third factor. I mean, when you insert dielectric inside the capacitor, potential difference will reduce, electric field will also be reduced because of that polarization effect. And if the potential difference is decreasing, capacitance will increase because they are inversely proportional. Charges will remain the same, constant. So this is the effect of dielectric on capacitance. So there are two conditions. There are two situations. In first one, we charge a capacitor through a battery, then we disconnect the battery and we insert one dielectric material inside. So in that case we know that my capacitance will increase k time, right? K time of the original one. Charges will remain the same. Potential difference will decrease k time due to that polarization effect. My electric field will also be decreased due to that polarization effect. Okay, so molecules of the dielectric will create their electric field in the opposite direction due to the polarization effect. So electric field intensity will get reduced inside, and energy stored by the capacitor will also decrease. Acha, I have not explained this energy stored by the capacitor, so let's check that as well. So basically when we are charging a capacitor, it will store electrical energy, right? So this is the formula for that. So basically battery provide potential difference. What is the basic formula for potential difference? Work done per unit charge. Okay, so this work done is stored as a energy. Okay, let me write it this way. So this work done is stored as a potential energy in the capacitor. Now this is mentioned in your class 12 textbook. Okay, class 12th textbook, physics textbook, that half energy will be stored as an electric field and half is wasted as a heat. So energy stored by the capacitor will be half of this energy, means V into Q. Okay, V into Q. So this is the energy stored by the capacitor. Acha, wait a second. Let me write this formula in terms of capacitance. So we know that Q is equal to CV. That was the first formula we saw. So ये V की जगह मैं क्या पुट, Q को मैं रिप्लेस करता हूँ, ठीक है. तो Q की जगह पे मैं क्या लिख सकता हूँ, हाफ V, क्योंकि यहाँ पे क्या आएगा C V, टोटल क्या हो जाएगा हाफ CV स्क्वायर. Okay, CV square. So let me write down the formula here. Half QV, that will be equal to half CV square. So as you can see here, if the V is decreasing, okay, my energy will also decrease. Or else we can use this formula. Let me erase this part. Let us use this formula only. So if V is decreasing, obviously U will also decrease, because charge is same, charge will not change. So this is the effect of introducing dielectric in a charged capacitor. Now this is second condition. Second condition, I am going to charge the capacitor, but I will not disconnect the battery. I mean, battery will be connected. Okay, suppose that I charge the capacitor using 10-volt battery. It is fully charged, 10 volt. Then I will not disconnect the battery, but I will introduce one dielectric here. In that case, what will happen? One thing we are sure about, capacitance will increase K time. Okay, original capacitor. Capacitance will always increase if you insert dielectric. What will happen to potential difference? What will happen to electric field inside? And what is going to happen with U, electrical energy? Let's find out. Yeah, this is the case when battery remains connected and you introduce dielectric material. So obviously my capacitance will increase. And since capacitance is increasing, इसका मतलब क्या है? Ability to hold more charge. Since battery is connected, it will provide more charge. So the charge will also increase in this case. Okay, when the battery is connected, the capacitance will also increase. Hence, battery will provide more charge to the capacitor. In this case, potential difference will not decrease. It will decrease anyway, but since we are connected capacitor to the battery, it will compensate that loss. So V will not change, electric field will not change because battery is still connected. Energy will increase in this case. Energy will increase. Why energy is increasing? Let's find out. What is the formula for energy actually? U half Q into V. So V is constant, okay, but the Q is increasing, okay, K times. तो मेरा energy भी K times increase होगा. Okay, so these are the factors. Okay, this is how capacitance, energy stored, charge stored can change with the application, with the introduction of dielectric inside the capacitor. So they do ask, actually they generally ask question based on this. Okay, when the battery is connected, what will be the effect on electric field, potential energy or potential difference, etc, etc. So today's lectures were regarding this only. Okay. So let me repeat once again. When the capacitor, you charge the capacitor and you disconnect it and introduce the dielectric, capacitance will increase, potential difference will decrease because of that polarization effect, K times. Electric field will also decrease due to the polarization effect, and since these two are decreasing, so total energy stored will also decrease. Charges will remain the same, charges will not change. But when you charges through a battery and battery is still connected, in that case capacitance भी increase होगा, charge भी increase होगा, but V, E and U will remain same because battery is still in connection. Okay, so remember these things. They ask question based on this introduction of dielectric.